Good morning, guys. So this is a video that you may never watch. I am recording this video just in case I am not here tomorrow, and I'm in the hospital. Hopefully I will be here tomorrow to teach this to you guys, but if not, the substitute's going to be showing you this video, and you can also watch it at home on my website when you're doing your homework if you need to reference it to remember what we did in class. So this is the warm-up for today. Not going to grade it on accuracy, but you are going to turn it in to the warm-up bin to see if you get a stamp and get it right. So I do want to go over it. So the first thing is understanding what the question's asking. It says we're going to look at the graph and determine whether each function could be used to model that graph and explain your reasoning. You don't have to technically show tons of work. This is more just understanding basic components of an equation. First thing I would start off with when I'm looking at A, B, and C to decide if it could match that graph is the A value, because that can immediately tell you if it's no. If it's yes, we need more support. But if it's no, that's one thing that we can just cancel out and move on to the next one. So for example, in letter A, we have an A value of +2, meaning the graph should open up. Looking at the graph on the right, it opens down. So therefore, no, this cannot match it, okay? The graph that we see opens down, not up. All right, and that would be a good enough explanation. For part B, we have an A value of -5, which opens down. That does match the graph, but that's not quite enough to say yes. We need at least one or more other characteristics that can support our decision. So this is in vertex form, and the vertex of this equation is +6, +2. Both positive numbers would put you in quadrant 1 for the vertex. And quadrants go 1, 2, 3, and 4. So that's a possibility, right? 6 up 2, even though there's no numbers here. And when there's no numbers, keep in mind that that graph could have been scaled as well. So that could be counting by 50s for all we know. But that's definitely a possibility. That matches up. That would be enough for me to say, yes, this could work. If you wanted more support, you could say something like the A and the Y of the vertex have opposite signs, -A, +K, which means 2 roots. And this graph has 2 roots. So all of this information combined would be enough to say that this is a possibility. Now, on your homework tonight, it's going to look like this, and there could be more than one right answer. So just because I said yes for part B doesn't mean C is automatically a no. It could also be a yes. We're trying to figure out all of the ones that could possibly match up with that graph. So part C, I have an A value of -3 opening down. That's good. And then this is an intercept form. So intercept form, the easiest thing to check would be the intercepts. So if I find my x-intercepts by setting x + 5 = 0 and x + 8 = 0, you would get -5 and -8. Negative x-intercepts, it should cross the x-axis to the left. If we look at this graph has positive x-intercepts. It's crossing on the right side of the graph. That does not match up, okay? Our graph has positive x-intercepts. It does have 2 like this, but they can't work. So this would be a no. The A value was good, but when we found more information, we have to decide that it does not match up. So the homework, like I said, is going to be like this tonight. And the rest of class today, we're going to be focusing on some real-world examples. So I'm going to pull that document up next, and we're going to work on this together. Actually, before I do that, I'm going to draw this quick little picture here. And you'll see this in one of my later videos as well. When we're working in the real world, and we have a parabola, something being thrown or dropped or anything that goes up and then down again, it doesn't even have to be an action. It could be just some other situation in the real world where it has its ups and it has its downs. we have to focus on what the question is asking us to find. The main goal of today is going to be to find the vertex of our real world situation. You're going to see words like minimum, maximum, highest, lowest, least, the greatest, the most. All of those key words are going to hint that that problem is asking you to calculate the vertex by whatever method necessary depending on the form the function's in. So that Freyer model with the boxes that summarizes how to find the vertex will come in handy. There are also going to be some questions that if I had a parabola like this and I'm like, how far did it jump? Then, sorry guys, I had to pause. There was someone at the door real quick. So I was saying if we have a graph like this, there's going to be questions that ask you, like, how far did it go? That's referring to the x-intercepts, which at this point in time, we only know how to find in intercept form. So if it's an intercept form, obviously we can find the x-intercepts to figure out how far it traveled. But the other ones in this packet are going to be set up and designed where it's going to start at 0, 0. And if, say, the vertex was at 5 or 7 or 10, you could just double this to figure out this number. So say the number in the middle was 5, then the total distance would be 10. So all the examples where I ask you how far something goes are purposely set up so they would start at 0, 0. If the problem doesn't start at 0, 0, like this first graph I did, if you doubled this x of the vertex, it would not tell you how far it went. Okay, that would not be an accurate depiction. So let's go ahead and try a few of those examples. First one says, at a circus, you volunteer to be shot out of a cannon. If the height of the circus tent is, and normally I'd have you guys just pick your own height between 30 and 40. I'm not here to do that with you, so we're going to just pick right in the middle. We'll say 35. 35 feet, if that decides to show up. There it goes. And I want to know, will we hit the ceiling of the tent? There's a function here that models our height after t seconds. Even though the problem defined our variables for us, we're going to define them again. So in this equation, t is representing seconds, and h is representing the height of our body as we're flying through the air in feet. If you don't know what your variables represent, then you're not going to know how to label your answers when you get them. Every problem, you're going to indicate what variable you're solving for, and as soon as you get a number, you're going to label what that number represents. Every single time, I'm going to be looking for that. And this handout that you're going to finish tomorrow and turn in on Monday will be graded. Okay, so I will be looking for that when I grade it. I will be grading this, not the substitute. So this doesn't use any of those keywords like maximum, highest, minimum, lowest, those sort of things. So we have to just visually think about it. So he's being shot out of a cannon here. He's going up in the air and hopefully landing on a safety mat over here. If I want to know if he hits the ceiling, I need to know how high he goes, the highest he goes. So therefore, this would be a vertex question, even though it didn't use those key words. So sometimes you have to visualize the scenario. When we find the vertex in standard form, it's negative b over 2a. And that's normally finding the x first. I don't have an x. I have a t in x's location. So I'm labeling what I'm finding. I am finding t first, because t is our x, using negative b over 2 times a. Okay. I'm going to keep working with this fraction just because if I change it to a decimal, I'll have to round, and I don't want to round. This is going to become negative 10 over, I can put the 2 over 1 and multiply the numerator and denominator. 2 times 2 is 4, 1 times 3 is 3. So I'd get negative 4/3, which still looks a little confusing. If you were to type this into the calculator, you would have to do negative 10 divided by, and then the 4/3 would have to go in parentheses, so it's a fraction. But I would like you guys to realize that dividing by a fraction is always the same as multiplying by its reciprocal. So dividing by 4/3 is the same as multiplying by 3/4. And the negative you can move around, as long as it just stays negative. Putting the 10 over 1, and I'm going to get 30 over 4, which is 7.5. I got a number. I'm labeling that number. This number is representing a t value, which is seconds. That doesn't help me answer the question. The question wants to know, will I hit the ceiling? That's not involving time. But I do know it takes 7.5 seconds to reach the maximum height. That's our x-coordinate of the vertex. So then we're going to sub it in to find the y-coordinate of the vertex. In this problem, y is h. So I'm going to set up h sub v equals, and sub in my 7.5 for t, for my time. And solve. I'm going to get negative 2/3. If I do 7.5 and I square that, I'm going to get 56.25. And then when I multiply over here, I'm going to get 75. This I would do in the calculator, negative 2/3 times 56.25. Don't forget to put the negative 2/3 in parentheses. And I'm going to get negative 37.5 plus 75, which is positive 37.5. I got another number. I got to label it. So that number is an h value, which is height. And not only is this just any random height, this is our max height. This is how high our body is going to go as we are being shot out of the cannon. Still haven't answered the question, though, which was, will I hit the ceiling? So let's go back to the height we chose here. We said the height of the ceiling was going to be 35 feet. Our body wants to go 37.5 feet. So our body is going higher than what the ceiling is. So therefore, yes, unfortunately, we will hit the ceiling and get a few bumps and bruises. So we're going to write a sentence to answer the question. Yes, I will hit the ceiling because, and then I'm going to say something about comparing the feet measurements. 37.5 feet is larger than 35 feet. There's the ending. So just, again, want to emphasize the things I'm going to look for. Label the variable you're finding. Label your answer when you get a number. Label the variable you're finding. Label the answer when you get the number. Write a sentence. And it's also very important that you first define your variables so you know what labels to use when you're solving. We're going to do another one together. I'm going to clear this out. Okay, so let's do number 2. We have another function which is used to model the height in feet of a kangaroo in terms of its distance in feet as the kangaroo is hopping around the outback. This equation is in intercept form. I could rewrite it if I wanted to as x minus 0 times x minus 8. So intercept form. So we won't be doing any, intercept. We won't be doing any negative b over 2a for intercept form. We're going to redefine our variables. So x, if we look in the problem, is our distance in feet. And h, it tells us, is our height in feet as the kangaroo is hopping. So he is hopping around the outback. Whoop, hopping kangaroo. So for part B, I want to know how far he jumps. How far he jumps is a horizontal distance, which has nothing to do with the vertex. This is not a vertex question. This is referring to x-intercepts. Well, luckily, it's in intercept form. So I can take my factors that have the x and set them equal to 0 to get my x-intercepts. The first one, since it's just a plain old x, there's no solving to do there. He starts at an x-intercept of 0, like in the drawing I just did. And then the other one, if I add over the 8, my other x-intercept is 8. Make sure you guys are writing everything down that I'm writing down, including the fact that this question is referring to the x-intercept. So he starts at 0, and he lands at 8. Therefore, how far did he jump? He jumps 8 feet. So 0 feet to 8 feet is a distance of 8 feet. Let's pretend the kangaroo started at 3 feet and landed at 15 feet. How far would he have jumped then? So 3 to 15 would be a distance of 12 feet. So you'd have to subtract those in that type of problem. Part C says find the kangaroo's maximum height. That word right there should be the key word, that this is a vertex question. So not x-intercepts. Well, I'm in intercept form, so I got to get the vertex using the intercept form strategy, which is not negative b over 2a. It's averaging the x-intercepts. So we're going to label what we're finding first. Whenever you do vertex, we get the x-coordinate first. Average the two x-intercepts together, and 8 over 2 is 4. I'm going to label that number. I got a number. I'm going to label it. This number is x. If I go back to part A, x is distance. So this is feet, but this is our distance. So if I go back to my drawing, that means the kangaroo reached the vertex at a distance of 4 feet, which makes sense. It's in the middle of 0 and 8. Now I have to sub that in to get the y of my vertex, which I actually should not have used y. I should have used h, which will give me negative 1/5 times 4 minus 8. I'm going to work through simplifying this. I'm going to go ahead and actually multiply the 4 times a fifth by putting the 4 over 1. That will give me negative 4/5. That's a 4 up top there. And 4 minus 8 is negative 4, which I will again put over a 1 and multiply across. Negative 4 times negative 4 is 16/5. And real world, I am 100% okay if you change these to decimals. So if I do 16 divided by 5, we're going to get 3.2. And I'm going to label that. This number is an h, which is a height. So this is not just any old height. It's the height of the vertex. So it is our max height. That's the number that answers the question. You'll see a lot that the question will ask for something that you can't find right away. I wanted height, but before I find height, I had to find distance. So look at the question, see what it's asking, go through the steps, and label everything. Okay. We'll do one more with you guys in class, and then the rest is you can work on tonight, and you can also have most of class tomorrow to work on. Tomorrow will also be your graphing quiz, so there will be a graphing quiz tomorrow. Number 3, we're not going to do together. I just want to point out that a lot of these are big decimal numbers. You're going to have to use calculators to work through those. And I am going to be okay for part B if you round to a whole number. Okay. Don't round until the end, though. All right. So while you're doing like the negative b over 2a and subbing it in, try not to round to a whole number then. But at the end, say you got like 50.78432. You can round that to 51. So for number 3, you can round to a whole number. And then the other one that we're going to do together is number 5. So we have a bottlenose dolphin, and he's jumping out of the water. The path that the dolphin travels can be modeled by this function, where h is the height in feet and d is our horizontal distance in feet. Part A, define our variables. So d is horizontal distance, tells us right in the example in feet, and h is height in feet. Okay, so we have a dolphin jumping out of the water. I would like to point out in this example, which is in standard form, that the c value is 0. The y-intercept is 0. That means it's starting at the origin and the dolphin jumps out of the water and lands somewhere over here. So I told you that all the ones that will involve distance, I'm going to have start at approximately 0, 0. We don't know how to find x-intercepts in standard form. That's standard form. We'll learn later, but right now we don't know how to. So for part B, it says find the maximum height. That's the key word again. Maximum means we need to locate the vertex. It's asking for height, which is y. I can't find y first. I have to find x first, even though I want y. So we're going to have to find the x of the vertex, which I should not use x. In this problem, x is d. So d of the vertex will equal, in standard form, we have to do negative b over 2a. So 2 times negative 0.2. This is going to be negative 2 over negative 0.4. And if you do that division out on the calculator, we are going to get, I believe, 5. I'm just going to double check that real quick. Yeah, 5. I got a number. I need to label that number. So if I label the 5, looking at my variables, this is a distance. So this is 5 feet, and it's a distance. This is the distance it takes to reach the vertex. That means in my drawing, it takes 5 feet to reach the vertex. It's an x value. If I sub that in to get the height of my vertex, because that's what the question ultimately wants, we will have negative 0.2 times 5 squared plus 2 times 5. This will become negative 0.2 times 25 plus 10. If I go ahead and multiply that, you're going to get negative 5 plus 10, which comes out to be 5 again. You happen to get the same answer. We got 5 for the distance, we got 5 for the height, which is why it's important you label both of them to know the difference between the two of them. So this is a height, and that's what the question wanted. So I'm going to put a box around that answer. The question wanted to know the maximum height of the dolphin. So he jumps a height of 5 feet. For part C, how far he jumps, if I look at the drawing I sketched, that's from here to here. Those are x-intercepts. As I mentioned before, we don't know how to find them in standard form, but because it has a y-intercept of 0, I could use the idea of doubling the x of the vertex. Okay, so we are going to double the x of the vertex, which in this case is the d variable, so d of the vertex. So that's going to be 5 times 2, which is 10. So he would jump a total distance of 10 feet. Okay. So the rest of the problems in this packet, there's 10 total, and we did 3 together, so you have 7 to practice on your own. It's going to be a mixture of standard form, intercept form, and vertex form. Remember, depending on what form it's in, you find the vertex using a different strategy. So keep that in mind as you're working through these. Your homework tonight is to continue working on this, plus you have a homework worksheet that looked like today's warm-up. And then tomorrow in class, you're going to start off class with a graphing quiz. You'll get around 15 minutes or so on that quiz. The more you practice graphing, the quicker you're going to do on that quiz. If you just get that quiz tomorrow and stare at it, because you don't remember how to graph, then it's going to take you longer than 15 minutes, but that's all you're getting, because if you know it, you should be able to execute it. And then after the quiz, you'll have the remainder of the period to keep working on this real-world packet, and this real-world packet will be due on Monday. And that is it. This is a backup video. Even if I see you guys tomorrow, I'll still post it, and you can go back and watch it to help you with your homework if you need to.